Hello, I've had a question in Unit 3, Lesson 6, and that's limits of trig functions. I've had questions about 19, 33, and 35, so I'm going to do them in one video. So for the first question, the thing to remember or to analyze here is exactly that we only have an issue with a limit if the denominator is 0. So in this case, the denominator is a 1, which means we have no issues. So we can go ahead and just evaluate this particular question. So that means it's going to be the square root of sine of pi by 6. All right, and we can, you can leave it at that. That's 30 degrees. So if I use my special triangle, 1, 2, root 3, so that one's going to be pi by 3 and pi by 6. So special angle here, sine of pi by 6, opposite over hypotenuse, it's the square root of 1/2. 1 over root 2, or sometimes the answer they'll rationalize the denominator, which means we'd end up with root 2 over 2. All right, but I'd be quite happy. In all honesty, on a test, you can stop right here because you've really analyzed the limit at that point. All right, looking at number 33, the easiest way to analyze this is to break it into two limits. Because there are two terms in the numerator, I want to analyze them one at a time here. And the other reason I'm doing that is because I have sine x and sine 2x. So they're not common, they're not similar terms, so I can't common factor. So I'm going to look at it in terms of the limit as x approaches 0 of 2 sine x over x cos x minus the limit as x approaches 0 for sine 2x over x cos x. So in the first limit, I end up with sine x over x, which means that that part of the expression is going to go to 1. So that's the limit as x approaches 0 for 2 over cos x. Now I no longer have a problem in the denominator, so I'm just going to move along to the next step. So that's going to be 2 over 1 or 2. Now moving to the other side, I need a 2x on the bottom. So this is what I'm going to do. I'm going to multiply the top by 2, but I can't change the value of this equation. So I'm going to have to multiply the bottom by 2. So I haven't changed the value of the equation. 2 over 2 is 1, so I haven't changed it. But what that provides me now is sine 2x over 2x. And that part of my expression then will go to 1. So I'm left with the limit as x approaches 0 for 2 over cos x, which is 2 over 1, which is 2. And now we end up with a value of 0 for that particular limit. All right. So there's 33 taken care of. On to 35. So the first thing I always try, is there factoring? No, there's not factoring. So what I'm going to do is I'm going to get rid of tan. Not a big fan of tan. Now tan, when it's in the denominator, so tan is usually sine over cos. Because it's in the denominator, it's going to be cos x, 1 minus cos x over sine x. So there's the problem right there. As the limit goes to 0, sine x is 0. So we got to deal with that in some form or fashion. So when I'm looking at this particular question, the only option I have, since there's no factoring and no identities at this point, I'm going to have to multiply by the conjugate. So squeezing it in here a little bit more, we're going to multiply by 1 plus cos x, and hopefully multiplying by the conjugate provides me with some help. So what does this limit become? It becomes cos x. That's a difference of squares, so it becomes 1 minus cos squared x over sine x bracket 1 plus cos x. Now we know that 1 minus cos squared x from our identities can be rewritten as sine squared x, sine x over 1 plus cos x. I have a sine on the bottom. I have 2 on top, so that'll reduce the exponent to a 1. So that means that I have a limit. The limit as x approaches 0 of cos x sine x over 1 plus cos x. Now I can evaluate it because our denominator is no longer 0. So we know that cos of 0 is 1, sine of 0 is 0 over 1 plus 1, which means it's still 0 over 2, or a value of 0. All right, so good span of difficulty or style of question. 19 is, it's actually one that I'm always asked by students because you're expecting something complicated, but at the end of the day, you got to remember that limits are to deal with when we're dividing by 0. If we're not dividing by 0, there's no issue. 33 is an excellent example. If we have two terms in the numerator, I couldn't factor, there's no identity there. Break it into individual fractions, and then you find that it's not as bad. Then 35 is a little bit more challenging. You can't factor. Getting rid of 10 didn't really help per se. And then it's an example of a conjugate question. So good breadth of questions. If you have any questions with any of the three of them, let me know and I'll try to explain further.